Hello, welcome back, guys. So today we are going to have our day 2 workshop to Unix command line. The title today is about the advanced usage of command line. So yeah, let's just continue. For this day 2, we are going to learn some very useful commands for the file processing. And especially we are going to learn about 3 major categories: set, AWK, grep, and also we are getting some kind of understanding about regular expression. And so for today's slides, as usual, we have this arrow denotes we have a code chunk, and which you can just copy and paste to your terminal and run it. And the link, the hyperlink of the slides is underline. You can click and open a web page. And there are also some practices in this slide, which will start with this yellow little man. And yeah, because this is like a hands-on workshop, so we will pause from time to time to let you practice with it. And after that, I will show you guys how to finish the practice tasks. And as usual, this is a 3-hour workshop, but we are not going to teach 3 hours continuously. It will be divided into 3 sections, 45 minutes teaching, and then 10-minute break, and then 45 minutes teaching and 10-minute break. And the rest of the time is teaching and also answering some questions. And for today's topics, it's mainly about how to request resources on the Hoffman 2 cluster. So especially if you recall yesterday, we told that when you log into the Hoffman 2, it's on the login node. The login node is like shared by everyone. So you are not supposed to do any heavy computing work on the login node. But if you want to do some computing, you should request another node to finish that. So the first one we are going to talk is how to request the resources. And also we are going to teach some useful commands for file processing. Like if you want to like view the file, there are also other commands besides cat, the one we teach yesterday, we taught yesterday. And yeah, as I said, we are going to learn three tools and the regular expression. So as usual, you can always go to the Google Doc to put your questions there. And if it will help you to illustrate your situation, you can also paste a screenshot of your computer so that I can know, okay, what's going on with your computer. And I have to see this remote teaching, like Zoom teaching. It's kind of challenging because I cannot see you guys in person. I cannot see the face. So I don't know like if I go very fast or should I go slower. So it's kind of challenging for me for the very first day. But I believe this time I should have a better control over it. Okay. So probably we can start it by give a brief summary about what we have learned yesterday. So yesterday we learned how to collect to the Hoffman 2 cluster through this COI, which means command line interface. So for the specifically, if you are a Windows user, you can use Mobile XTEM or WSL, the Linux subsystem on Windows, to open a local terminal. And if you are a Mac OS user or Linux user, just open the terminal. So after that, you will get a window that waits for your input of command. So you can just log into your Hoffman 2 by running this line of code, SSH username at Hoffman 2 idre.ucla.edu. Just replace the username to your username. And then we talk about how the Unix file system looks like and how to navigate through the file system. So we talked that Unix is a tree structure, and the files folders, they have this from root to the end of the file is called as the absolute path. And usually, yeah, your terminal is on a folder. Like if you are not first log into the Unix, you are in this home folder. So the path that is relative to your current folder is called the relative path. So those are I believe it's a very important concept when you're using the Unix. And also we talk about the home folder is a tilde, like it can be represented as a tilde. And one dot is your current folder, and the two dot is the parent folder, which is one level up of your current folder. And we talk about how to log into Hopman2, and we also learn how to exit, close the collection from Hopman2, and then return back to your local computer. Just use the exit. And the three different commands we learned is pwd, trying to print your current working directory. Change working directory, you use cd, and ls is just trying to list what's in this folder, and also some other information like the date of the file and the size, well, sort of things. And there are some tips we covered yesterday. You can use the up and down key to go through what command you have been used in the history. And you can use this tab key to automatically fill in the full name. And you use clear to clean the screen. And and always remember, if you don't know where are you and what's in this folder, you can always use pwd and ls just to check. For example, if you want to create some file, some folder, and you don't know if you have successfully created it, you can just use ls. And we also covered how to make a new file directory yesterday, like make directory and touch, how to remove them, copy them, and move one file to another. Also move can have a function that we can use it to rename a file or a folder. And we also talk about how to get the content within a file. We use cat and print it to the standard output. We also learned that we can modify a file using this VI editor. And if this file is not existing, and then you can actually just use this to create one. And we also go over the file permission and how to change the file permission, use the change mode. And for the rest, it's like if you want to compress a file, you use gzip, and if you want to compress a folder and everything within it, you use tar. And also the last 10 minutes or 15 minutes, we also talk about how to do file transfer using command line, and also using other GUI tools like CyberDoc or Mobile X10 to download and upload files between your computer and the Hopman2. And finally, we talk about how to get help using Unix. You can use man with using this double hyphen help. So always remember that the command line is case sensitive, and you can always, if you don't know what's in this file, you can always use cat, trying to print the files to the terminal. And so far, if you have successfully mastered the knowledge we have taught yesterday, and I believe I have just go over it for you, so you probably have some impression on that. And now it's time to fight the dragon. So here is actually us, like our new beginners. We have some basic knowledge about Unix command line. And today we are going to go over all those like five-head dragon. Like we have AWK seed grip. We are going to talk about regular expression and some of the advanced usage of command line. So the first thing is trying to request the resources on Hofan2. And I believe you probably have tried on your own that you collect your Hofan2. And then if you want to request another load, like interactive load, you can just try this command, qrsh, the -l, and also hrt equals, so RT here means running time. Here I just use 3 hours, like 3 hours, like the hour, minute, and seconds. And there is a comma, and here is the H data, which means how many like memory do you want to request. So here, because we don't really need a very big memory for today, so I just use 256 megabytes. So remember, there is no space between the comma and the H data. So you probably just, the best way is just trying to copy and paste to the terminal. So this if you don't specify the running time and the H data, it's just will use the default setting for you, like 2 hours and 1 gigabyte. So if you are like doing some heavily computing work, just remember to request enough resources for your computing jobs. For example, if you are doing some like the alignment jobs, like you have some sequence data and you want to align the data to the reference genome, so probably you will need a much bigger memory than 1 gigabyte. And another thing is that we have tried this yesterday, so I don't think you need to try this again. So if you haven't have this working materials on your Hofan2, you can just copy this one. And if you have, you don't need to redo it. Okay. So this is just a git clone the repository to your folder. And another option is trying to download the file. Just click this link and download zip, and then uncompress it, and then upload to Hofan2. So this will make the life a little harder. But yeah, it's another way if you don't have access to Git or something. And yeah, we have covered this. So today's useful commands for file processing, well, I just categorize them into these 4 different classes. And as we said yesterday, that the Unix philosophy is that it treats everything as a file. So the file processing is essentially here quite important. So the first one is to view a file. We have talked about the cat yesterday, and today we are going to learn the more or less or head or tail. And so if you are going experiencing with some GZ file, the compressor file, you can also just use the zcat or zmore. So here is like the detailed for each command. For the cat, this is just trying to get the contents of the file and then direct it to the standard output, which is our terminal here. And so this one will extract all the contents of the file and then print it on the standard output. So it's not suitable if you have a very large file. So just think that maybe you have 1 gigabyte of files and then print out them on the output probably will be too crowded for you to recognize everything. So it's not really suitable to view a really big file. And but this will be quite useful if you are just using facing with you are facing with a very small file like tens of lines sort of things. And another command is more, which is just trying to view maybe the first several contents, like one screen at a time. So if you type in more, for example, you go to the day2 folder and then type in more HE38, and then it will print something like this. And also, because this is like a print one, view the content one screen at a time, you can actually scroll line by line if you press enter, or you can just scroll by screen. You just just press the space key. So after you finish the viewing, you can exit, just press Q. So it's fairly simple. You can try it on your own. And the next, so you can think of more and less. They are like something like contradictory to each other, but actually here they finished some kind of like a similar tasks here. So this one is will display the file in a paginated way. So each time it will print a page of the file. So if you still with your own effort, you can just try less and the file name. And so if you want to scroll line by line, you can use the up and down key. And if you want to view page by page, you can use F, which stands for forward, or B, which stands for backward, like go through one page from another. Or another option is you can use page down, page up if you have this key. And also the exit option is the same. You can use Q after you finish all the viewing. And there is also a search option for this file. For example, you use a backslash some string. For example, you can backslash CHR. It will print. It will try to search the strings forward. And if you use the question mark, it will search backward. And the small the encapsulated N is like the next occurrence, and the capitalized N is the previous occurrence. So you can just go from one line to another that matches your pattern. So this is about more and less. And here we're going to talk about head and tail. So as the name suggests, a head is just trying to show the very beginning of the file. For example, you can use head dash this hyphen, and then use a number, and then with your file name, it can print the first several n lines of the file. For example, here, I just want to know, okay, what's the first 10 line of the file? So I just use head the -10 under the file name. It will print from 1 to 10, 10 lines. And the tail is also has a similar usage. You can just tail -10, and then it will print the last 10 lines of the file. So this is kind of like useful when you really want to have a very large file and you just want to get a quick sense, okay, what this file is about, what's the format or something like that. So you can just always use the head and tail just to get a small segment of the file. And also you probably will face some of the compressor file, and zcat and zmore is similar to cat and more, but they deal with the compressed file. So this decompress is like it will try to understand the compressor file and print it to the standard output. So this is very similar. So I'm not going to put a lot of efforts for explaining that, but you can just as I tried here, you can just use Gmore, trying to know what's the first several lines it looks like. And one magic usage is that we can use cat to merge different files into one, or you can just merge them and print them all to the output. For example, you can cat file 1, file 2, and then it will print, okay, this is the file, and yeah, this is the contents. So I was trying to ask the question, does the order matter? So for example, if we switch the file 2 with file 1, like cat file 2, file 1, what would be the output? So yeah, I think I probably just would see the answer that it will just switch the order for this part and this part. So the cat is always trying to read the first file first, and then the second file, and then the third file, and then print them sequentially to the standard output. So the order doesn't matter. Like if you switch here, chromosome 210, chromosome 110, switch them, the order will also be switched. And one little trick about using a star to as a wildcard. So this actually means, for example, if I want to get the content of all files that are started with CHR, and we can simply just use the star here. That will shows the contents of the files whose name starts with HR. So actually here, the star just means everything, like yeah, just means any strings, any symbols, any characters. So for example, if you use the star 10 here, that means it will belongs to the files that end with 10. And if you use this star at the beginning and star at the ending, so this will just list all the files that contain a CHR in the name. So actually here you can see if we try this, we have three files that ends with 10. So it will just get listed out. So also if you use this command, it will print out all the files names that contain CHR, like the very first two, and then this one in the middle. Yeah, while I was talking, you can just try it on your own. So I think this is a good time to do some practicing as we go over those commands. And in the meanwhile, I will try to look at the chat box to answer some questions if you have.
I get no such file or directory when I try to use that file.
You mean do you have this QC bio command the folder?
Yeah, it says I already have it when I try to redo that.
So can you go to the QC bio, just cd into the folder and then cd into the day 2? So it should be there.
Okay, I'll try that.
Okay, sounds good. It should be there. And actually, I have a question from the chat box for, do you need a new file name for the merge file by cat? So yeah, this is actually a good question. Here, what I just talked about using cat, it's just trying to cat the file, like get the contents of the file to the standard output, which is your terminal. We are not doing like create a new file, but later we will talk how to do that using cat. So yeah, so for this practice, I can demonstrate with you guys how to do it. Yeah, so first you enter into the day2 folder, and there is the HG38 file here. And we are going to scroll line or page using NAS. Let me see. Okay, if you are like view line by line, you can just use enter, press enter key. And if you are going to do it with page, you can use a space or the F4G as we taught. And if you are trying to search, you can probably use \CHR. Then it will show you the lines that started with the CHR, contains its CHR. And for the second, the task is trying to merge. So we can just cat the first file and the second file. Then it will print out all the combined contents. So we can actually check the first one. It's looking like this, like Unix is cool. So this is the first one. And starting from this to the end is the second one. So here is the answer to the practice. And probably we can continue. So one previous question, I think it raised out a very good point that if we want to cat the file into one, merge them into one, and make a new one instead of just output to the terminal, how would we do that? So actually, we can use this redirection, which is like the greater than symbol here. This will output the file, output the contents that is on the terminal, supposed to be on the terminal output to a file. So if this file exists, it will overwrite it. So it will just completely remove what's in the original file and then create a new one. And if you don't want to overwrite the file, you can actually use this double symbol, double greater than symbol. So here it's just like the trying to append the output to the end of the file. If the file that doesn't exist, it will just create the file. So here it's actually it's what I tried using echo. So echo, this is day two. So basically this will print this is day two, this string to the output, the standard output. And then I just redirect it to a file called test.txt. So after we do that, we can see, okay, because there is no file before, test file before. So after that, we see there is a new file created. And then if we get the contents of this file, we can see that there is a this is day two. And if we use this double greater than symbol here, we actually can append this new line to the end of the file. So this is what I tried. You are really encouraged to try this on your own. And also there is the how to say, this is a technology called pipeline. So basically what we did is trying to get the output of command 1 as and redirect it to the input of command 2. So sometimes this will be very useful if you are doing some complicated work, like you don't want to generate the intermediate files. For example, you can generate a file for the output of command 1 and then use it as the input to the command 2. You can bypass those file generation process just using the pipeline. So here is what I do for this pipeline. So basically, what I did is trying to get the first 10 lines of this compressor file. So here, I just use tcat to cut all the contents of this GZ file, but I only select the first 10 lines of the output. So I use the pipeline here and use the head -10. So it will just print out the first 10 lines of this GZ file. So this is just a simple example of this pipeline. And one good advantage for this is it can avoid generating the intermediate files. For example, one traditional way is trying to, okay, first decompress this file to a regular file and then use the header 10. So you can you actually experience one extra step. You decompress it first. But here, what I did is just trying to, okay, do all of the tasks within one line. So this is actually very useful. I use it a lot, especially when coupled with the grep command or awk command. So yeah, this should be quite useful for daily use. And also we can have other kind of functions. For the first several, we talk about how to view a file using different commands. Here, we can also try to sort a file. So this is a sort command. It can sort the lines in a file. If you put into some flag options, for example, you want to sort by a specific column, you can use this -k. And if you are trying to specify the delimiter, which usually is 4 spaces, or you can the delimiter it's a comma or something, you can use a -t. And if you want to sort by the numerical value, you just simply put this -n. So in default, by default, the Unix will sort by alphabetically. So like A to Z or something. And if you want to reverse the sorting, you can use this R, reverse order. And yeah, there are also some other commands. For example, ignore the blanks, only use the unique lines. And if you really want to output the sort to another file, you can use this O here, trying to specify the output. So by default, this sort will output the results to the standard output, which is your terminal. So here I can just show you how to by example that if we take a look at the very original file of HG38, it will be this kind of thing. But if we want to sort, for example, sort by the column 2, and from big from small to big, and by the numerical value. So actually, I just specify K here. I want to sort by the column 2, and I want to sort by the numerical value from the small to big. We can also just check that by viewing the output that is from small to big. So yeah, so this is a very simple example for the sort. And here I also use this pipeline here, just trying to print out the first 10 lines of the results. So this is about sort, and we also have other commands specific for a file. For example, we have count here, just trying to count how many words in the file. And actually, you can also put different flags into that. For example, you want to know how many characters in the file, how many lines in the file, or how many words. So here is just like I tried. So CHR1 underline 10. I just want to know how many lines is there. So I just use the -L. So there are actually 10, which is designed by me that I specifically just get 10 lines of this file. So okay, this is the count. And also we have cut that we want to just get a specific part of the file. So we, for example, we have so many like strings in the file, and we probably want to select, okay, I only want the second characters of each line, or we want to have, we want to just the second column of the file of each line. So you can use the -C, -F to do that. And usually your file probably have some delimiter. For example, if it's separated by a comma, you want to take that into account, you can just use -D and use a comma. So here is another example I tried to show you. For example, in this 6 file list file, we actually have the format has showing like this, and I just want, okay, everything before this underline. So I just cut them. So we just take the first 10 letters of this file, so it will output a sample A01. So everything before this underline will be kept. And yeah, this is just a simple case for using cut. And also, you probably will experience the file have duplicate lines, and you can always use unique to extract the unique lines out of the file. And here is the option. You can use -C, -D to show like how many times each line occurred, how many duplicate, and also if you use -D, it only shows the duplicated lines. And here is what I tried. If we put this unique in this pipeline, so previously it will have duplicates for each line, and after we do that, it will remove, only keep the unique ones. And if we count for each line, we actually can know, okay, sample A01 appear twice, and also other lines appear twice. So this is kind of useful when you have duplicates in the lines. And if we want to compare 2 files and try to find the difference, you can always use diff. So here it's the syntax of this command, and you can choose let's see the -C, -U, -Y, just trying to know how these 2 files differ. So here is what I tried with -Y. So it will display mode chromosome 10 and mode chromosome 1 10 on the left side, and the other file on the right side, and it will denote, okay, the first one is modified. The second one is like the second file contains containing a line that is not in the first one. And also for this one, the first file contains this line, but it's not present in the second one. And for the rest, without any symbols, it's all the same. So this is just actually trying to compare 2 different files with each other. And so this could be quite useful if you have multiple copies of files and you don't know if they are exactly the same or if they have some difference. You can always try to use a diff. And if these two files are exactly just copies of each other, it will output nothing. So like if you don't put a flag here, just diff mode 1, chromosome 1, 10, chromosome 1, 10. So they're actually the same file. So if you run that one, it will output nothing, showing, okay, these two files has no difference. They are the same. They have the same contents. Okay, I think we can just take the 10-minute break here. And while we are taking break, you can try this practice. And I will see you in 10 minutes. Okay, yeah, welcome back, everybody. We will go over the solution for the practice. So for the first one, it's trying to sort based on the column 3 for file sample A01.gz. So probably you, if you just trying to cat this file, it will show a very weird result output because this is a compressed file. So that will give you some kind of random symbols to your output. So it's not recommended to do that. But what we can do is trying to use zcat, zcat sample, this one. We can use a pipe to do the sorting, if you like. But first, I want to look, okay, what's the format of this file? So we can see, okay, this is what this file is about. We have this set column, and here, let me do the sorting, which is trying to sort based on the column 3 by numerical value. So I need a -n here. And here also it wants to do the sorting by decreasingly. So that means because the default is to sort by increasingly. So we need to use the flag with -r, which is just trying to reverse the sorting from bigger to smaller. So here, let's see what would be the results. Okay, so here is a command I just run. I use more just because I just want to try to check the results. So we can see that we actually sort by the set column from big to small, like decreasingly from this biggest one to the smaller one. So to the end of this smallest. So actually, this is how we did the first practice. I guess one thing you can learn from this is that, okay, dealing with this GZ file, the compressor file, you should use zcat. And if we want to use sort numerically, we use -n. This is just for the set column. And if we want to do it decreasingly from big to small, we should use this -r, which is trying to reverse the total order. And here, I also want to mention the pipe I use here. I use a lot of pipe just because we want to finish all the tasks within one line of code. And this is very useful to do that. All right, this is about the first task. And for the second one, we want to use car to extract the sample ID for the SIG file list.txt. So probably we can see this is the file contents of this file. And we want to use a cut. So we can use, let me think. Okay, we still are going to use a pipe that, as we have seen in our previous slides, that we can cut the underline of the file, right? So this will give us, oops, sorry, I should try to, oh, let me see. Yeah, let me go over the original. Yeah, because I always forget things. That it's likely that we can always check the slides. Okay, this will give us the sample and the sample ID. So here, basically, what we need to do is just trying to restrict our cut within this within these characters. So one simple thing is trying to, okay, we just cut from, let me see, 1, 2, 3, 4, 5, 6, 7, 8, from 8 to 10. Probably it will solve the problem. Okay, here we go. So this is what we get, and we can use the unique to get the deduplicated sample IDs, because each sample have two line of records. So this is how we did it. And alternatively, if you want to like make your life harder, I guess what you can do is trying to cut another time. So this is not the smartest way to do it, but you can also try to cut, okay, yeah, 8 to 10 maybe. So this will also help. But yeah, I talk about this is just because we can always try to use the pipe, like get the output of our previous command and redirect it to the next command. So this is the same thing with the cut this 8 to 10. Here, I just want to show the usage of pipe. All right, I believe we have finished all the tasks. So we probably can move back to our teaching for the advanced command line tools. So the advanced command lines, here we are going to go through these three, and also the majority of our today's talk about seed, AWK grep. So seed is actually a non-interactive file editing tool, and AWK is more like a scripting language for the text processing. And the grep, as we have seen before, if you want to search a specific string or a specific pattern in the file, you can use the grep. So here, let's dive into the first one, seed. But before that, I want to remind you about VI. We have talked yesterday that VI is an interactive editor that it requires you to do the editing by your hand, right? So this is just a simple review for how to use VI. You enter into, when you edit some file, you enter into the insertion mode by press I. After that, you can use the escape to jump out of the insertion mode and enter this column W to write the file, WQ, right hand quit the VI editor, and then Q exclamation mark to just get out of the VI editor without any modification, just force quit. So This is the interactive editor. You must edit everything by your hand. But it's also not so useful in some cases. For example, if the file is just too large to be edited, for example, you have 1 GB of file, and then this file is simply too large. When you use VI to open that file, it takes maybe forever to open it because it's so large that it must load it into the memory, and then you can do the editing. So it could be very slow to load them. And also, if you have a lot of like repeated items, the editing can be complicated and tedious. For example, you need to edit it line by line through your hand. So that one, in that case, you probably will feel boring after 1 minute. You have so many lines to edit it. So luckily, Seed is actually some automatic tool for us to do some kind of editing, and it's very fast, use a very little memory, and also it can perform multiple editing in one pass. So Seed is actually I should call it a seed or something. Seed, yeah, stream editor. So it will parse and transform the text. The usage of seed is kind of simple. Like we can use seed and with some flag, and also here is the commands you want seed to do, and the last one is the file name, the file you want to edit. You want to edit, and the editing tasks can be like you want to insert a line to some specific location, or you want to append a line to the file. You want to delete a file, delete a line in the file, or you want to like substitute one string by another string, or also you can just simply modify something, and also you can try to subset the file, like you just want a section of the file. So here the flag option usually contains 2. One is this I, the -i. You want to edit the file in place. That means you just want to modify the file, so you don't want it to be output to the terminal. And another one is if you have a lot of editing, you probably need to use this -e. Try to put a lot of expression one by one, so you can just finish all the editing in 1 line of code. So the first one about editing is trying to insert. For example, here I just give the syntax that the seed x, y, I here means the insertion and some kind of pattern or some kind of string. So here it's like explanation about this code. It will insert this pattern line before each line between x and y. So here is just an example that for chromosome 1, 10, this file, if we don't do the editing, it will just have this as the first line, the following as the four lines. But if we want to insert a new line, which is a string, between 1 and 2, and so after that, after we finish the insertion, we can see for the first line, we have this new line inserted before, and for the second line, we also have a new line inserted before. So remember that between x and y actually includes x and y. So this is just a very vivid demonstration that 1 and 2 is actually included. So this is the insertion, and so another thing is that the insertion can also be found, or the places can be found using some searching mode. So previously we just used the line number, which line we want to insert this new line. But here, actually, we can ask the seed to do some searching. For example, it will insert the pattern or the string before each line when this searching pattern is found. So this is just like the syntax we have. So this backslash, everything in between is just a searching pattern you want to find. And here is an example that we want to find all the lines of NNN that have NNN, and insert a string called new line before this lines that matches our searching pattern. So here we can actually find that besides this chromosome 1, which has no NNN, so it will have no new line inserted before. But besides that, except that, like all the lines that contains NNN has a new line inserted before. So I hope this could be a useful thing to use, especially if you like really want to do some editing based on your file pattern. Like you want to insert some line before some kind of mark, and then it could be a good thing for you. Instead of just editing line by line by your hand, you can use a seed one to help you do that. So this is the insert. We talk about how to insert by the line number. You specify the location, or you just specify a pattern, let us see that you find the lines. And this is about insertion. And the second one is append, just trying to append the line after the line, after the specific line. So this is very similar to insert, but instead of before, we just do the append. That is, we paste the new line after each line. So here it's very similar to the insertion. We just simply use A instead of I. And so this example is also similar to previous one. We found that after we put A here instead of I, the new line is actually appended behind the line we specified, the line 1, line 2. So we have a new line as the following. And so this is like the slight difference if we compare with the previous example. And also we can just let the seed to find the pattern for us. So this is also a really similar example as the previous one. We just simply replace I by A, and after that we found, okay, all the lines that have N has a new line appended to below. So yeah, this is similar to what we have found. We have seen before. So insert and append. So the next thing is about how to delete a line in the file. So we can use similarly delete lines between X and Y. And here we just simply use D, which stands for delete. And this is the example that we want to delete the line, the chromosome 1 line. And I believe it will also include X and Y. So actually, if we specify 1 and 2, it will delete the first 2 lines. Yeah, it should be. So that's about the delete. And also we can let the seed to decide which line to delete. So previously we just put okay, which line to delete, like the first line, second line, the line order. And we also can ask the seed to find the line that have a specific pattern and then delete it. So here is that we tried okay, if you find this this greater than symbol, then delete this line. So after that, we found, okay, the first line is removed from the output. Okay, this is for the substitute. So sometimes when we want to replace one string by another string, for example, you probably will need to replace sample A1 just by A1, right? So actually you can use this substitute syntax, which is just trying to, okay, put a S, still remember there is a single quote to wrap all these things together. You put an S in the front and then specify two patterns. So this first pattern is the pattern you want to be replaced. And the second one is you want to edit. So for example, here, what I did is just trying to substitute the CHR by an empty string, which means we want to delete all the CHR in the file. So after we do that, we can find, okay, previously, this should be CHR1, CHR1. If you cat view the file of this, we use the file contents of this file, it should be CHR, CHR1, right? And after we do that, we will see, okay, the first CHR is removed. So this substitution, one thing should be noted is that it only applies to the first match. So the first CHR will be removed, but for the second one, it will be kept. And if you want to remove all the CHR, like replace all the CHR, you can just simply add a G to the end of it, right? So the G here actually means globally, which means we want to do the replace for the whole file. So after we do that, it will actually replace CHR for both of them, in the whole file. And here the replace, because I just specify a empty string here, we don't put anything for the pattern 2, so it will just replace like by empty, which means we just simply delete CHR here. So yeah, this is another way we do the deletion. And here I just show these two examples for you, and probably you can try it on your end. So after we talk about the substitute, like we do the first match, if we don't put the G at the end, and if we can also do it on like globally for the whole file, if we put a G. And here actually we can specify what scope we want to do the replacement. For example, I just try to use replace what the symbol between 1 and 5. So this will only limited to the scope you have specified. For example, here it's what I did. I want to remove the first n, the 5n, first 5n, right, in the first 5 lines. So actually you can see, okay, only the first 5 lines get modified, the rest is untouched. So this is actually a way that you can restrict your replacement. You just want some small part of the file to be replaced and leave the rest alone. So this is how you do it. You just specify the range here. And if Y is set to be a $sign, that means okay, starting from this line to the end of the file, you want the replacement to happen. So here it's just like a quick symbol. You don't really need to know the total lines of the file. You just simply put a $sign. It means, okay, that to the end of the file, we want the replacement happening. Okay, so far we have talked about insertion and append and deletion and substitute. So I think this could be very useful if like avoid you just editing line by line using the VI editor. Here we are going to also talk about how to modify a specific line. So here you can just use this syntax that you want the X9 to be changed. Here C denotes to change and with your new line. So you just, for example, here, what I did is just trying to, okay, we want to replace the third line as a hello world. So here we can see after we run the code, the third line is changed from the what NN to a hello world line. So this is actually can let you do some specific editing of the file. And also we can subset the data using, for example, you just want the middle, like between like N and M, these middle lines. You can actually use this this -n and specify the range and with a P. So here, still the X or Y are both included in the output. So here is what I did. I would just want the fourth line to the sixth line. And okay, the output we got is okay, the fourth for the original file and the sixth, it will only output 3 lines. So this is for the subset. You just want a part of the data, part of the file by line. And we have also talked about how to run many commands using a tag like the -e in the very beginning. We talk about the text, the -i, -e. So here it's actually how to run multiple commands in just one single pass. That is, we want the X between X and Y, we want to delete, and between S and T, we want to append a new pattern, new line. So this is what I tried. So actually using this -e, we can combine a lot of things in one single command. And for example, here, I just want to insert a new line ahead of 1 and 2 and change the third one to hello world. So this is actually the output. And instead of, yeah, here is just like some suggestions. Like we talk about this, that there is a -e, which can combine a lot of things in one set, in one seed command. And also there is also a -i, which means we want the modification to happen in place. That means we don't want the output to the terminal, but we want to just do the modification on the file. So one common mistake we would make is that we probably will do something like this, just trying to do the editing on the file and then redirect the output to the file. So this actually will give you some issue that all the file in the end will be empty. So instead of doing that, you can actually read and write in just using this the -i. We want the modification happen to be in place instead of creating a new file. And also, sometimes you are not sure how to use the seed command. And usually, if you want to do some editing in place, it's better that you back up the file before you do this command. So this is just in case you make some mistakes and totally ruin the total file. And also the backup file is simply just copied to make another copy of it, right? So I think we have go over all the seed here, and probably it's time to ask you to do some practice, and I will give you maybe 3 minutes to finish this. So maybe I can show you guys how to finish this. First, I copy this from someone, then from someone, test. So we created two test file, and simply just copy the file, the command here, and from someone. So here we found that, okay, when we cut this this new file, we didn't find anything. This is because, as I said, that when you try to do the whole thing, and then it will output the results to the terminal or standard output. But after you redirect it to the original file, it will overwrite the original file, but in the end, it will be an empty file. But if you want to do the modification on this place, in place, you should use this -i command. So wait a second, let me see. Oh, yeah. Here, another thing is that when you copy and paste, sometimes the hyphen will not be copied properly. So just try to remember when you copy and paste and find errors, try to check the command. So after trying, we can cat it. Okay, and we found, okay, the insertion is successfully. There is oops in the line 1 before the line 1 and 2. So I guess this can be a very good way that can enhance your impression on how to do the editing in place. Try to use this command, this flag, instead of try to redirect. Okay. So the next thing we were going to learn is the AWK, which is here. So so previously we have learned that the seed can help us to edit line by line, and here AWK will do something for us in a more flexible way. And actually we can do it, for example, we extract a specific column, and we also want to do some numerical operation on the columns. And one thing I think I want to mention is I found a very good question in the box, in the chat box of Zoom. So probably I will do another way. So one student said that the way we do the cut is using the character position 1 to 10 to get the samples name. So in our previous practice, and okay, he thinks, okay, this is a very tedious way. It's not very convenient to use, and asked if there is another optional way we can do it, like more elegant or more easy. So actually, this is a good attitude when learning Unix, right? because we want to be lazy. We want the machine to take care of everything we want, right? We don't want to spend the extra efforts if we can spend less. So actually there is a good way to do it. So remember we have talked about the delimiter. Okay, here. The delimiter here, if we want to cut it, for example, let's just take a quick look at those. So we can cut first by the underline, and then after that, we can just take a look what's the output. Oops. And yes, usually I think that we cannot directly see it here. Usually it will cut into different pieces, and we want the first pieces. So we use the F, which means extract the first field, and we can take a look here. Oops, sorry. I guess I forgot to input the file name here. Okay, I guess this is wrong. Let me do it again. Forget to input the file name and more. Okay, and this will give us everything before the underline. And then after that, we remember that we have a pipeline that redirect the whole thing to our next command. So we can do another cut that we do on this little hyphen here, right? And then this time we want to keep the second field, right? Because we cut this one. So this is the first part, this is the second part. So we can use -F, second part. Right, so here we will just keep the second one. So this is an alternative way to finish that task, and I hope this one could be a much easier way. Like you don't need to count what direction or what position we want to keep, but instead we just want to keep like finding some delimiters and then keep those in between. All right, this is about the previous tasks. And now let's officially move to the AWK part. So the AWK syntax is also quite similar to what we learned with the seed, that we actually have some flags. And the different thing is that we can do some more flexible things, operations within this AWK. For example, we can put a condition here, and within this condition, we can do some operation. And then the final part is also the file name. So the condition can be something like a search pattern, and also it can be some comparison. For example, we want some field, some variables to be greater than a threshold or equal or not equal. And we can also use some keyword like the begin, which means the beginning of the file, end of the file. And operations can be, for example, output a field of the file. It can be some arithmetic operation. For example, you want to do some calculation, like adding one column with another column and output the sum. And also it can be more complex logic. For example, you can do if else, like still, yeah, you can do a lot of flexible things there. And the flex option can be the capital F, which is trying to specify a delimiter between columns. For example, sometimes we use the comma, and sometimes we use a tab, which is just 4 spaces. And we can also do the -V which is trying to revert or inverse this week here is just trying to give a variable a new value. So here this v is followed by variable assignment statement. So don't confused by the v we have seen previously. The verbose were reversed or something. Yeah. So yeah, this is just the flag options. And I want to teach this part by different examples that can be very useful. For example, this operation, as we said, we can print, use a printer to print a certain columns here. So here we use AWK to print the first column. So here $1 means the first column. And specifically for column 2, we can use $2 and so on. But there is one thing about the whole line is $0. So $0 is the whole line. Okay. So this is just the task we finished, that we print the column 1. And so this is the result I run. So you can also run it on your own by your side. And another thing is, if you want to print a lot of things, like column 1, column 2, you actually can just put the column 1 with a comma, column 2. And so remember, if you don't specify the delimiter, output delimiter, it will be just a single space here. And we will talk about later how to specify that. For example, you want 4 spaces here, or you want a comma here. We will talk about it later. And also you can, when you print something, you can also add something before or after that. So you can actually print for each line with a contig, and then you print the first column. So this will give you the results you desired. And also you can do some complex operations. As we said, you can calculate the sum between 2 columns. So here is what you did. So you just simply print the 4th column, add the 5th column. So this will give you the results, the 4th column, 5th column, and add them together as the output. Also, you can do other operations like minus, multiply sort of things. So this is just showing how to do the operation just with the addition example. And so this is just about the print. We learned how to print a certain column using AWK on the file. And we also want to talk about some built-in variables that is in AWK before we move on to the next part. So there is NR, which is the number of records seen so far. So because you can view it, it also processed line by line. So the number of records is like the current records you are in. And the number of fields of current records is similar to the number of records. And the FS is like the input field separator. Like we can specify it in the delimiter. We want, for example, if you have a comma separator, you should set FS to be a comma. And the OFS is similar to FS, but it's just like the output field separator. So remember that when we see, if you don't specify this, it's just the space between the two output. And if you want a tab, you should set OFS to be a tab. So yeah, let's move on to the concrete example of each of those things. So one thing is that, for example, when you are do some searching, like you want AWK to do the searching for you, so you actually can just simply put this searching as a condition, and with the parentheses with your operation. For example, here is an example that if you found this CHR in this line, you just print the number of records of the line, right? So here is just what I tried for this file, and it actually can print. Okay, we found CHR in the first line, so we print 1, and in the second line, print 2, and so on. So you can try it with the 4 line. It should be ended at this 125. And we have seen that FS is like the failed separator. OFS OFS is the output failed separator. So here is an example that we use this. For example, we want to similarly we want to search the CHR and then just print out the first 2 columns, right? Like if the line has the CHR matches with this pattern, we print the first 2 columns. But here we just do want it to be printed in our desired way. For example, we know that the file is separated by a tab in the original file, and then we want I want the output to be separated by a comma here. So we just specify these 2, and then after run it, we can see that okay, from the chromosome 1 to chromosome M, there are 25 lines that matches our searching pattern, and we print the first 2 columns and then separate them by a comma. So this is how we did with the searching, and also specify the separator of output. And also, besides the string searching, we have gone through, and there is other searching that we can use a condition. For example, we only want to keep some lines that fits this condition. And in this condition, we actually want, okay, the second column is smaller than a value. And then if it's smaller than a value, then we print the whole line. So this is how we did that. We just put the second, and then this is our condition, and this is our operation. Remember that the $0 is the whole line. So after we run this command, we actually see, okay, the second column is smaller than the desired threshold. So we print it out, and all others, like the chromosome 1 to Y, the second column is greater than this, so we won't print it. So this is an example that we can do some condition control and then print the whole line just by in this condition and operation way. And also you can just extend this example to others. For example, you want equal, greater than, less equal, or something like that. So you can just, based on this example, you can extend to whatever forms you like. And also I want to tell a little bit more about conditions, is that usually you are not satisfied with only one condition, right? You probably will, okay, you want 2 conditions combined. So here it's a way that you can combine the 2 conditions. For example, here I just use column 2 less than this value, but greater than another value. So you just need a double AND to combine these 2 conditions together. And the output is showing like this. And we can see what the files, what the lines it outputted satisfy this condition. And also you can extend this one to all, or to simply to not. So this is another extension you can do if you have some some kind of requirements. For example, only satisfying one with them. Okay, I guess it's a time that we can take a break, and we will come back and for the following part. So maybe I can show you guys how to do this. Yeah, let me just clean my screen. Okay. So this is a practice for AWK, and we want to know. We want to finish this following 3 tasks. So the first thing is that it's a diff file. So we use dcat to extract the contents, like from the compressor one to the output. We can first take a look at what that file looks like. We use a more with a pipe, so it looks like this. And the first one is trying to ask us print a column 1, 2, and they are separated by hyphen. So we can maybe we can just go back to the previous one. So if you notice that if we want to specify the hyphen, we should use OFS. So here we just input fs equals t, because it's separated by a tab, and we want the OFS to be a hyphen. And the next thing is that we want to only print the first and second column. So we will print. Let me try this if it works. Let's see. Let's see what's going. Yeah, so still I will kind of make mistake because this is not something to keep in mind. It's just that when you feel okay, you have this need, you go to the slides, and then just following the example on the slides, and then finish what you want. Oops. It seems like we have something not good here, but that's okay. Let's try another way. Yeah, the problem is that we should add a V here. Yeah, so just remember, when you follow the slide, make sure it follows all the format. So, okay, this is what we got. That we print the column 1 and 2, and they are separated by a hyphen, right? So this is where we have, like, we specify OFS with the hyphen, and then print column 1 and 2. All right, this is for the first tasks. It's not so easy, so don't be frustrated if you cannot get it right. Just try to remember what I tell you, that if you want to finish this, go over the slides, find what you need. And the second one is trying to filter the sites if it's not CG. All right, so this will just be the if else, the if command we have. We want to filter the false if it's not CG. And then we print out the whole line. Oh, like that. It says filter size is not, so we will only keep. Oops. Oh, let me try it again. Okay. Condition for equals CG. The print zero. Let's see. Right. Yeah. So you probably will face the same issue as I did, that you only put the carry brackets here. I forgot to do that before. The fourth is a CG. Okay, so we successfully finished this second task. So remember you as I said, that you probably will run into some issues when finishing that, but just check the command you input, and you probably find, okay, something is wrong, and you fix it. And then, for example, here I make mistakes for not putting the symbol correctly, and then I didn't put a double quotes wrap around the CG. So after I fix that, I will get what I want, that the fourth column are all CGs. So this is task 2, and the print this $0, which means we will print the whole line. And this if condition means we only execute the operation after we found that the fourth column is CG. So here, I hope I can give you a demonstration on how to understand the code. And the third one is to calculate the sum of the last column. So we still will try to follow the slides, how to calculate the sum of a column. We use this command. So this will give us a sum plus, actually I forgot what that data look like. So this is 1, 2, 3, 4, 5, 6, 7, 8. The 8th column is the last column. So we will do AWK and the sum plus column 8, right? And then end to the end of the file. So that's how we calculate the total sum of the 4 column. And let me see. Okay, I should remove this single code here. Probably that's it. Yeah, we have 130 as the total sum. So yeah, I think just as I did, you simply follow the command in the slides and try to modify it, adjust what you need to, and then try to run it. If you found something wrong, then go back to check the command and then try it again until it has succeeded. So I guess that's all about the AWK. So our final, the second, the last but not least is the command grep. And I think this could be kind of useful to you guys, and we will go over it. So the grep is actually a global regular expression in print. So it will do the searching of a specific pattern for you, and then print it to the standard output. And also, if you really want the results in a file, you can redirect using a greater than symbol to create a new file or something. So here it's a flag option. The V here it means we don't want this pattern. So it's an inverted match. So instead of like matching to this thing, it matches somewhere else. So this is not confused with the V, the flag V in AWK, which means we declare a variable. And in others, it will be like verbose. But don't try to memorize those things. If you need to use it, you just go back to check the flag options. But do remember there is the invert match. And N here is the line numbers of the string occurs, and C is the count of how many numbers of lines. And we also have this I, which is the case insensitive. So that means if you put a capitalized N or capitalized letter, you use the I, it will also match to the uncapitalized one. So this is called the case insensitive. So we also have other things. I'm not going to give a very specific detail about that, but you are free to check them or try it on your own. So here, for example, I still try to teach this part using different examples so that you can go back to this and when you face some similar issues. So for example, we want to find the substring of the grep, right? And so for example, I want to find the lines with the CHR. The simplest one, like the syntax is trying to grep with a flag, with a pattern and your file name. So here I just use grep CHR and this file. So it will output all the lines that contain a CHR. So this is quite simple. And so if we want to find lines that without CHR, so what do we do? This is like the flag I told you. We do the inverted match. Just put a -v here, and it will output all the lines that don't contain CHR. For example, for the first several lines with the CHR, it will not show in the output. And we also have other flags that can finish something that probably is what we want. For example, we can count the number of lines that have CHR. So one thing is just trying to use the -c here. C means count. We want to know how many lines have CHR. So here it's the results 25, 22 auto sum, column sum, 2 X, Y, and M. So another way to do it is trying to do the word count line. So we have gone through this at the very beginning of our workshop today. We just simply use grep the word contents, and it will output the different lines, and then we simply count how many lines of the output within this pipe. So this will give us the same answer to that. So grep also have extension that probably we want to find a substring in multiple files. So one thing is that you simply put the additional file with a space to the original one, and it will output, okay, we found CHR in this line 1, CHR in this line 1. So this is like how we did with the multiple files. And also, you can just ignore the -n, which will output the number of lines. You can just use the gap that's this -l, and try to find all the files that contain CHR. So this is a practice, and I guess yeah, this part will be relatively simple. So I will give 2 minutes to let you finish that. So probably I can do it do it at the demonstration. So we want to count the number of lines whose contains GL. So we can use grep GL in this HG38 file. And because we want to count the lines, so we use WC-L, the -L. Let's see, there are 16. So we also have another option that we can use the -C. This will probably give us the same results. And another thing is the second task, count the number of lines who doesn't contain KL. So we use the inverted match. And still, because I'm more familiar with the order count command, yeah, we can just get the results. So this is about the tags. Right. And so the final thing I want to talk about is a regular expression. So yeah, this part is more like additional thing I want you guys to know, but you don't have to master it. I just want to know there are something called this, and it's something fun. So actually, the grep is a tool that we can, although we do some searching for the substring, we can actually use some regular expression for the searching. And the regular expression is just a sequence of characters that specify a such pattern. So for example, in our daily life, we came across different patterns. For example, your UID, like the university ID, it's a 9 digits number, right? A string. And if you have of course you have a phone number, and then usually is in this format that 3 digits is wrapped around in a parenthesis, and then followed by a hyphen, and then 3 digits, and then a hyphen, and then 4 digits. So it's always this, right? And also our address is like can be separated into five segments. And the first segment is usually a straight address. So it's a combination of numbers and characters, right? Alphabetical characters. And the second is a room number or building number. So it's also a combination of numbers and the characters. The third one is like a city's name. So it's usually a characters, it's a string. And the fourth one is like the abbreviation of the state. California is CA, maybe Texas is TX. So the fifth one is just a zip code. It's a 5-digit number. So here we can all see there are so many patterns we are experiencing every day. So the regular expression is just trying to use the formula to describe the patterns. For example, we have talked about the patterns of each segment by our own natural language, right? But the computer cannot understand the natural language, so we have to use this regular expression. It's more like a computer's language to understand those patterns. So this is a regular expression in like the overview, and more specifically, the regular expression can be just a sequence, like a substring. For example, here CKS, and actually because a lot of words have this sequence, so it can match to multiple places. For example, the Unix tool sucks, right? It's a match, and the Unix tools rocks is also a match. So it can match to multiple places. And something I want to stress here is that there are some rules to write a regular expression. For example, we can use a single dot here that it can be used to match any characters, like any symbols, any numerical numbers, or any like the alphabetical numbers. So for example, O.K here, it can match to anything 3 I think it's three, contains 3 letters, and the middle one can be any character like Fox, OK. So the middle one is O, and this one is a C. So you can have 3 matches. So you can actually copy and paste the command. Probably you should type in on your own and try to locate. So the double hyphen color here will highlight the places it matches to. Okay, the dot can be used to match any characters. And if you want to match a dot itself, for example, sometimes we have a single dot at the end of the sequence. And clearly this time we want to make it more like more original, not it represent any character. We simply just use the escape before the dot itself. So this will denote the dot itself instead of any characters. So here is the example that if we just use this O and dot, we can actually match to 2 places. Although this place is a space, it can be matched. But if we want to specifically restrict it to a dot itself, so we can just use the escape, and then it will only match to this place. Okay, and also you can try the command if you like. It's fun. And also there are another rule that trying to that we can try to use is this squared brackets. So this can be used to match any of the options in this in this brackets. So basically here, the regular expression, that means we can match to B80 bit, BOAT boat, and BRAT bread. So this one, that means, okay, any characters within these options should be a exact match. So as we can see that if we write the regular expression in this way, it can match to 3 different places on this sentence. And if you want that, if you want that it doesn't match to the characters you specified, you can simply put this symbol before like within this formula. So in this way, the only matches to characters that don't that is not E and O. So here you only have 1 match. And there is also a short abbreviation if you want to match digits. You can write 0 to 9, or you can just write a column, digit and column. So this will give you the same. These 2 are the equivalent. And also, if you want to just match 2 alphabetical characters, you can see A to Z and a capital A. This should be a capital Z, or simply you can use this one. And if you just want to match the digits and the alphabetic characters, just as I said, you want to match the first 2 segments, the street address, the room number. You can, so it's a combination of the numbers and the characters. So you can just use those, the characters and the digits, or simply you can just use this one. Okay. This is just a simple practice. Probably, I think, yeah, it's very easy. So I just give 1 minute to let you try to think about it. Okay, I think the only one needs an answer is the first one. The second one is just trying to repeat the code. So the first one, we want to match both the capital F FASTQ and capital F FASTQ. Simply, we can use the one we talk about that we want to match any of them. So it's just in this form, we put a brackets around F and F, so it will match to either this one or this one. Okay. And the second one is just trying on your end. It's fun, so it's not really something useful to the to your like research or something, but it's something fun to try it out. Okay, and for the rules, we have gone through the first two, and the third one, we have also gone through that. It's not for the first one. This one will means the beginning of the string that we want to match exactly a start of the string, and the $sign means the end of the string. For example, if we put this letter here, then we will only match to the very first, right? It's the beginning of the sentence, and if we want to just match to the end of the sentence, we use the $sign. So yeah, this is two symbol we can try to use for a specific location of the sentence. And there are also other things I'm not going to go into very detail about. If you are interested, you are very encouraged to try it out on yourself. So basically, this carry parentheses here, trying to match the pattern exact n times, or at least n times, at most m times, or between n and m times. And also, if you have some kind of alternative pattern, you can use this vertical line to denote that. And sometimes you have some repetitive patterns, so you can use a parenthesis to denote that. For example, if you use A star here, that means you will match to 0 or more occurrence of A. And if you ABC, it will only stick to C. That means you follow by 0 or more occurrence of C. So AB, ABC, ABCC, or many C's at the end. So if you want to match the whole string, you can use the parentheses for all of them. So this will give you ABC or ABC, ABC. So it's a repetitive pattern. And so I probably will leave this part to you as a after the work session or workshop session. So this is just a very simple summary of our learning today. We actually gone through a lot of things. This is just like at the very beginning, we know how to view the file contents using different commands, for example, cat and more and less. And if we just want to load the very first like 10 lines of file or the last 10 lines of file, we use head and tail. So if you are dealing with some compressor file, you use dcat or zmore. So this will show the contents of the compressor file. And we also go through the sort and some redirect command. And one very useful trick is to use the pipeline. And we also have those 4 different commands that is useful, is very useful in your daily life. Word count how many words in the file, how many lines. And we also have the cut, try to split the string into the different files, and then you just take the file that you want. And we have the unique to deduplicate, and the difference, try to compare if 2 files are the same or not. And at the last, we talk about 3 very useful command tools: seed, awk, grep. Both of them are for the file processing, and especially grep, we talk about the regular expression just now. So those are just something fun I want to teach, and probably if you are interested, you can dig into it. It has a lot of good, good, interesting properties and interesting options there. But I encourage you guys to try the examples here, and then try to get a sense of it. Okay, so probably I will go to the Google Doc for if you have any questions. Okay, this one. Okay, I guess we have solved all the questions on the chat box, and yeah, so remember we have the dragon at the beginning, so we are the little soldier with a sword and a shield. So finally, actually we through our today's workshop we actually killed the dragon, so we did it. And yeah, I guess that's the end of our today's workshop. And if you have any questions, you can stay here, and otherwise you are free to go.